Flutter is a way to create cross-platform apps, and you write them with the Dart programming language. So I figured that would be a good place to start. Dart was designed by Lars and Kasper Lund. Lars was also the lead developer on V8, which is the JavaScript engine that runs Chrome and a whole bunch of other modern applications. It seems like Lars formed his opinion while working on V8 that JavaScript is just inherently flawed as a language. You should just start again. That's why he wrote Dart, and he wanted that to be the main language for the web. This conversation between Lars and Anders Hejlsberg, who was the core developer on TypeScript, was quite interesting in hindsight because TypeScript kind of won. Both of these Danish computer scientists were trying to solve the same problem, which is like, how do you improve JavaScript? Felt like a classic engineering question. What do you do when you have something that isn't working well? Do you improve on it over time, or do you just start from scratch? I got sidetracked looking at the Dart.js compiler, JavaScript proxy objects, and the Desmos graphing calculator. And then I installed Dart, had a play with that on the command line. I love that all the tooling was included in it. You have a package manager and a way to test, compile your apps, all just within the same user interface. It came with some templates and the standard libraries that were quite easy to read. Dart can compile to pretty much every platform, and because Flutter is built on top of Dart, that means that it also can compile to pretty much every platform. One of the other things that Flutter relies on is Android Studio, so I installed that by itself so I could get a basic idea of how that works. And I also chose to use VS Code for my text editor, and I installed the Dart and Flutter plugins. I went through the code lab Write Your First App, which is recommended on the Flutter website. I got sidetracked for a while trying to make the code lab in dark mode. I was reading about Firefox's readability.js file, which turns things into reading mode. You build user interfaces in Flutter using what they call widgets, and you do that with this nested syntax, which I found a little bit confusing in the beginning, but after a while I became quite comfortable with it. Flutter by default uses Material Design, which is Google's design system. You don't have to use it. You can also use Apple's design system or just make up your own one. I quite like you can just hot reload, so if you change anything in the application, you can just reload it instantly instead of having to restart the whole app. I like that it just compiles to a Windows application, then I can try it on Android emulator, then I can put it on my phone. I went through the fundamentals part of the documentation. I got sidetracked reading about how hard it would be to release an app on the Play Store. And then I got started with the first major half of the documentation, which is the user interface part. I went through reading and trying out different pieces of code. I didn't really understand it yet, but I didn't stress about it too much. I went through lists and widgets, layouts, interactivity, tabs, creating new screens, and returning data from a new screen. I figured at that point I could probably create a little project. Came up with the idea of a shopping list app, and I broke it down into all the different steps and just built each one of those separately to slowly figure out all the things I didn't understand. And that was the end of my first week. In the second week, I thought it'd be cool just to continue on with the shopping list app. So I went back and designed it a bit more on paper. I also used the program Penpot, eventually used Indigrid, which is a cool free piece of software that I've been using recently. I realized my scope was just way too big, so I made it as small as possible and then drew up all the pages I would need in a web tool called draw.io and started building out all the components. Along the way, I found out about this thing called a linear progress bar, so I added that into the app so you could track the progress of your list. I finished the app and put it on my phone and had a little play around with it. I definitely ran into a couple of problems that I couldn't solve, but I was happy that it was mostly working and kept moving on. Then I went on to the second major half of the documentation, the beyond user interface. They introduced the idea of UI is a function of state, which took me a little while to wrap my head around. They talk about state management, which is how you pass data around within your app. I found this example page where they build the same app using multiple different state management styles. They talk about React, which is a framework from Facebook, which seems to be what Flutter was based on. And they talk about Redux, which I didn't really understand, so I used ChatGPT to help me create an example of how it works. They talk about app architecture, separating out UI, logic, and data. It was a lot of concepts, so I tried to diagram them all out so that I understood it, but it turns out on the very next page they had already diagrammed it out. One of the things they talk about is separation of concerns, which is a term that I've heard before, and it was coined by Dijkstra, who's also someone I've heard of before. There was this website which is devoted to all of his papers and things that he wrote, And I found the paper where he specifically wrote about separation of concerns called On the Role of Scientific Thought, which was quite interesting and funny. Lines like, from what we can know, we have very, very small heads. And then I got sidetracked by watching the series on asynchronous Dart and Flutter. And that was the end of my second week. In the third week, I got to the largest part of the documentation, which is the case study, which is an app called Compass, and it's a way to plan your holiday. I downloaded the code for it and had a little bit of problem getting it working on the Android emulator, but I eventually figured it out and started working through the documentation and looking at the code of it. There was a lot of new concepts in there that I didn't understand, and they used a lot of different packages. One of the packages was called Provider, which I'd seen mentioned a couple of times before. I was watching some videos on the guy who made that and trying to understand that, but I just wanted to learn Flutter and not really all the other packages. So I figured the best way to do it would just be build the absolute simplest to-do app that I could in one stateful widget, and then slowly build it up into the architecture that they recommend. I was trying to understand how inherited widgets work, and I watched this series, and then I watched this video about state management, and he talks about trying to avoid fighting the framework. And that is how it felt when I was programming a lot of the time and running into issues. So I figured I should probably understand what a declarative reactive framework is. I started by looking into React, which is a framework that came from Facebook. I watched this video when they released it internally within Facebook itself. From what I understand, the problem with the main framework at the time, which was Angular, is anything can change anything, anywhere, anytime, and that makes it really hard to work with. So it's better to just, anytime anything wants to change, recalculate the whole user interface. They also talk about Dijkstra. Humans are basically not very good at dealing with many changes over time. We're better at dealing with just one change at one point in time. I read this article by a guy who worked on Angular. I read a bit about ReactiveX and RxJS, some other frameworks, and a guy who worked on that. I watched some talks by him, and he was talking about pushing rather than pulling, which is another idea in reactive frameworks. And I also watched a video by him on functional programming. Then I was looking into Model View Controller, which is the original framework, and watched some videos by him. I realized dealing with things that change over time is kind of like one of the big problems that computer scientists have been trying to deal with for a long time. I watched this video by Tony Hoare where he talks about one way of dealing with that, where he came up with the triple, where you assert a precondition, you do your computation, and then you test that all your post condition matches what you think it would. I watched this video by John Backus where he had this famous paper on can programming be liberated from the von Neumann style. Then I was looking at Lambda calculus, watched this video where he was talking about how Alan Turing is basically not as important as we thought he was. And then also this guy who was around the same time as Alan Turing, and he created a similar kind of idea as the Turing machine. And that was the end of week 3. I was feeling pretty comfortable with the idea of what a reactive framework was at that point, so I just continued on building up my version of the use case. I was looking up a bunch of Dart concepts I didn't understand, and I got kind of stuck on the command and result pattern. This line in particular took me quite a while. I understand now it's a named factory constructor that calls a private named constructor. It passes a generic type, but it's also part of a sealed class. I don't know, I'm just not ready for that type of code yet. Use case also goes through testing. So I did this code lab, got sidetracked watching this video on xUnit, which is a testing framework, read some old articles by Martin Fowler, and read a little bit of the test-driven development book by Kent Beck. I had a bit of a big shift in my understanding of how to use testing. My usual method of programming is I'd write enough code to get it working and then start changing things over time and just keep reloading the program to see if it's working. But that's manual integration testing. I think a more efficient way would be separating out each component and writing tests for each component. And then anytime you update something, you just run all those tests again. I think all this stuff is probably obvious if you know it already, but it was my first time learning all of this. There was, of course, another famous quote by Dijkstra, which is, program testing can be used to show the presence of bugs, but never their absence. Testing is pretty good, but I won't catch everything. It was almost the end of the month, and I was a little bit disappointed that I hadn't made as much progress as I wanted to. I was reading this article on the 3 tribes of programming, which breaks up programming into 3 different archetypes. Programming as mathematics and correctness, programming as hardware and software and code, And programming is a tool to make things. You don't really care how it works, you just want it to work. I realized I probably spent more time on the first two than the last one, so that's probably why I wasn't feeling as happy as I wanted to. That was my month with Flutter, and I quite liked it.